Hi there, you're in the lab with your mate JJ. Today is Learning the Art of Electronics Day. Today we're learning the art of electronics. My silly job title for today is Wattage Warlock. Today I'm the Wattage Warlock. Of course, in the Learning the Art of Electronics videos, we work through the book with the same name. It's going to be a pretty quick video today because the experiment we're doing is really quite simple. So I'll tell you about it over on the bench. We'll go over, we'll do our experiment, I'll write up the results, we'll do our revision and look at the notes at the end of the video, and that'll be it. So it should be a pretty quick one today. So let's pop over to the bench and do our experiment. All right, well here we are on the bench, and I just want to skip ahead to where we're up to. Where are we up to? 1W, 1S. Here we go. This is where we're up to. Page 29, diode test. I'll just read through it and then we'll do the experiment. So it's just this small little chapter here. The DVM puts out, DVM is the digital voltmeter, of course. The DVM puts out a small current, usually 0.5 milliamp to 1 milliamp, and displays the resulting voltage across the diode under test. This function can also be used as a continuity test on many DVMs. If the voltage drop that results is very low, the DVM beeps. Measure your DVM's current output in diode test mode. Incidentally, you will notice that diode test provides a fixed current, something that can be useful for a variety of purposes. For example, you can use it to check whether a second DVM's fuse has blown. The process that we are here describing as a way to measure the value of a diode test current could also be described as an easy way to determine whether a second DVM's current measurement fuse has blown. No need to rig the 5-volt source and resistor that we proposed in section 1L.2.4.1 on the facing page. So that's it. We're just going to put our meter in diode mode and use another meter to check what current it's putting out. So I'll get set up. We can get it set up quickly. All right, so what we're going to be doing is putting the EV blog meter in diode mode and then measuring the current with the fluke. And then once that's done, we'll put the fluke in diode mode and measure the current with the EV blog. So we're going to put this into diode testing mode, which is here, and we'll just select diode. That's what we want. And then we're going to put this in current sensing mode. We'll put it in milliamps. All right. So we'll connect the common terminals, and we're going to want to run the common terminal here to the milliamp here. All right. Now that's making a lot of noise. I don't know if I can turn that off. How do I turn that off? I don't know. Alright, well, it's making a big racket. Gee, that drove me to distraction. I'll just see if I can figure out how to turn that beeping off. Hang on a sec. Alright, well, it turns out you can't disable the beep on the EV blog diode test. There's no facility for that. So I'm just going to do it with the beep enabled. We'll get the current written down very quickly. So we want to put this in diode mode, and we're going to plug it in. It's going to make a bit of racket. We'll get the milliamp reading off the fluke, and then we'll be done. Okay, so we've got 0.31 milliamps. Sorry about the racket. Now we're going to do it the other way around. Put this over here and put it on there, and send this in here. Now we're going to put him on milliamps. I'm going to put him on diode mode. There he is, diode mode. So let's plug that in, and we're reading 0.53 milliamps. There you go. So that was our experiment for the day. So let's jump over the computer together. I'll write up the notes and then we'll run through the notes for today. All right, I'm back. I was going to go over to the computer and write this up, but I decided I wanted to see what happens with diode. I can't take me anywhere. With diode attached, and we'll have the EEV blog and the fluke. This will be the diode test current. So this is the reading for the fluke, and we're going to have voltage and current. And for the fluke, the voltage is 0.554 volts, and the current is 0.40 milliamps. Now we're going to reverse it, so we'll put, we'll take everything out to start with. Put him in diode mode, that's right. And we're going to put this guy in current mode. All right. And it's not beeping because of the forward voltage. And that voltage is 0.527 volts. And the current is 0.26 milliamps. Cool. So now we've got a full set of readings. So I'll pop over the computer, write this up, and we'll go through them. All right, I'm back again. We are headed over to the notes, but I was there writing everything up, and we did this measurement with the 1N.2.4.1, and we got this really small reading. And they said that really these aren't designed to operate at these low voltages. So they said use a signal switching one as well. So I've done that, and that's what we're measuring here. So we've got the EV blog meter in in diode resist testing mode, and the forward voltage is 0.541, and the current is 0.26 milliamps, which is the same as what we saw last time. Okay, cool. Now just disconnect this, and that's going to go into current measuring, and then we'll put this in here, and this that can stay, and then we want this going. We've got to put him in diode mode, and not range. This one. There we go. All right, we'll plug him in there. Okay, and we're reading 0.567 and 0.40. Interesting. It's pretty much exactly what we saw last time with the currents. Cool. And these voltages are the same. Okay, fair enough. Fair enough. Okay, now that really does conclude the readings. I'll take over to the notes now. All right. Well, here we are on the computer. What are we working on? Learning out of electronics.
So we'll just go over to the ITL wiki. This is inthelabwithjj.com/wiki. The ITL wiki is where we keep our notes. Learning on the Art of Electronics is what we're working through today, second edition. Now, scrolling past the notes we've already made, over to lab DC circuits, which is what we're doing today. So this lab is to get you used to using the breadboard and the multimeters. We're not expected to find Ohm's law surprising, so we're just getting used to the equipment. You note that voltages are measured between points on a circuit, whereas currents are measured through a point in a circuit. Analog meters are known as VOM, short for volt ohm milliammeter, and the digital meters are known as DVM, short for digital voltmeter. You will also see DMM, the digital multimeter. To measure current, a DVM runs the input current through a small valued resistor and measures the voltage drop across that resistor. The small voltage that the DVM drops when measuring current is called the burden voltage. So we did an experiment to determine our DVM's burden voltage, and these are the results of those here. We looked at that last week. It was interesting, of course, to see that the burden went up when the precision went down. So as you measured smaller and smaller currents, you needed more and more voltage. It was interesting. Resistance measurement. It says here you should be skeptical when measuring components in circuit. It's best to disconnect at least one end of a resistor before taking a measurement. So that's good to know. Here's some other. Okay, this is an experiment. Try your DVM's resistance measurement. In this experiment, we use one DVM to measure resistance while another DVM measures the voltage drop during the resistance measurement. Ideally, the voltage will never exceed half a volt, so as to avoid powering diodes and transistors and such. The first set of readings are from when we used the EEV blog meter to measure resistance. The second set of readings is from when we used the flute to measure resistance. So they're separated into columns. There you go. So these were the results we got with the EEV blog, and these are the results we got with the fluke. Very, very similar, except for this one, which was a real outlier. It's like 10% of its value is missing. I don't know really why that happened. And diode test, this is where we are today. So in diode test mode, a DVM puts out a small test current, usually 0.5 milliamps to 1 milliamp. The DVM will display the voltage across the diode under test. If the voltage drop is very low, for example less than 50 millivolts, the DVM will beep as per continuity mode. And we actually saw that today. It beeped when we just shorted it out without the diode attached, which are these readings here. So to measure your DVM's current output in diode test mode. It can be handy to use the test current from a diode test mode to check a second DVM for a blown fuse. For testing today, we used two multimeters, the EEV blog BM2257 digital multimeter and the Fluke 17B Plus digital multimeter. You can click through for the details if you're interested in that equipment. We measured the current from each meter while in diode test mode with no component attached, so we just shorted it out. And when it was short, the current went a bit higher than it did when it was loaded. So we saw it delivering 0.31 milliamps for the EV blog and 0.53 milliamps for the Fluke. Then we did two sets of measurements, one for the rectifying diode and one for the small signal diode. It's actually funny, in both cases we pretty much got exactly the same results. The test current in both cases was the same. The Fluke was 0.4 milliamps, whereas the EV blog was 0.26 milliamps. And the voltage drops were within a rounding error of each other. They weren't the same, but they were pretty close. They were pretty close. And that's it. That's all that we've done so far. The rest of the chapter is still to be done. We'll continue working on that next week. So I'll throw over the third wall cam, we'll wrap up.
And that's a wrap. So that was a pretty simple experiment today, although we did one round, we did a second round, and we went back for a third round. So we got a whole page full of results. We tested with our EV blog meter, we tested with our fluke meter, we put them in diode mode, we looked at the current that they delivered, we looked at the voltage drop. We saw that when the input was directly shorted, that the EV blog meter will actually beep like it does in continuity mode if it's less than some threshold voltage. In the notes it said that the threshold voltage was typically 0.5, half a volt, I think it said, or maybe it was only 50 millivolts. Yeah, I think it was 50 millivolts. So that's 0.05, yeah, volts. Anyway, I think that's it. So we're done. So I hope you enjoyed this video. Thanks very much for watching, and please remember to hit like and subscribe.